In this video, we will look at Chapter 12, which is Optimization with Constraints. Please note that only Section 12.1 and 12.2 will be covered. So Section 12.1 discusses the effects of a constraint. A constraint places a restriction on where to find the optimum. So for example, there's an income is constraint on utility maximization, or a quota on production. So a constraint can cause a different optimal value than an unconstrained optimum. So there are two ways in which you can find the stationary values under a constraint optimization. So first we can solve using the constraint. So say we have utility equal to x1, x2 plus 2x1. So we want to maximize utility, but it's subject to the cost 4x1 plus 2x2 equal to 60, which is our income and the prices of goods. So how do we do this? We use the constraint and solve for x2. So from this, we know 4x1 plus 2x2 is equal to 60. That means 2x2 is equal to 60 minus 4x1. So x2 is equal to 30 minus 2x1. That means we now replace x2 into our utility function. So that is x1 times 30 minus 2x1 plus 2x1. That is 30x1 minus 2x1 squared plus 2x1. How do we maximize? We take the derivatives, we set the derivative equal to 0, and we solve for x1. So x1 is equal to 8, and we use this value to solve for x2. Where's our maximum utility? Is equal to 8 times 14 plus 2 times 8. And that's 120. How do we use our second order condition? So d2u dx1 squared is equal to minus 4. That is less than 0, so that means it is a maximum. The second way is using a Lagrangian multiplier. This you will have used in microeconomics. So we use our new function, which is z, equal to x1 x2 plus 2x1. This is u plus lambda 60 minus x1 minus 4x1 minus 2x2, and this is our constraint, which I have set equal to 0. And now we find the derivatives of this function. We set our derivatives equal to 0. So we can then solve. So you can use any of these functions and work backwards. So if we take 60 minus 4x1 minus 2x2 equal to 0, that means x2 is equal to 30 minus 2x1. We place that into our second equation. So that would be 30 minus 2x1 plus 2 minus 4 lambda is equal to 0. So that makes x1 equal to 16 minus 2 lambda. We place that into the third equation. So that would be 16 minus 2 lambda minus 2 lambda equal to 0. So minus 4 lambda is equal to minus 16, lambda equal to 4. x1 is equal to 16 minus 2 times 4 is equal to 8. And x2 equals 30 minus 2 times 8 is 14. Same answers as before.